Here's some sum and difference identities. There really, you could work on either side here, but I think it's easier to work on this side over here because it's kind of hard to recognize that you have sine of a plus b over here. So I'm just going to rewrite sine of a plus b using the formula. So this is the sine of a cosine of b plus the sine of b cosine of a all over the sine of a cosine of b. So just a little note that if I have 3 over 7 plus 9 over 7, I can write that as 3 plus 9 over 7, which is 12 over 7, which I don't really care about that piece, even though it's still true. Everybody's pretty confident that you can do this, provided you have common denominators. You can just add the numerators. So likewise, I can go backwards. If I have something over one fraction, I can break it up into two different fractions. So I'm going to break this up into two fractions here. So this will be the sine of a cosine of b all over the sine of a cosine of b plus the sine of b cosine of a all over the sine of a cosine of b. This cancels, I just get 1. And here, the sine of b and cosine of b, that is equal to tangent. And cosine of a, sine of a is equal to cotan. So therefore, I get these two are tan of b. These two are cotan of a. And I got it. Okay, so for the next one here, it's going to be easier actually to work on this side over here. But let's just cheat and just write this down so nobody can see it. This is really 1 over cosine of a plus b, where it's 1 over cosine a cosine b minus sine a sine b. So this is cheating, not really supposed to do this. So we'll just write it over here, and then later on, when nobody's looking, we'll erase it, and no one will know it's even there. So let's start on this side over here. Let's write everything in terms of sines and cosines, since this is in terms of sines and cosines. So this is 1 over the sine of a times 1 over the sine of b all over cotan is cosine over sine, so cosine a over sine a, and cosine of b over sine b minus 1. I have a common denominator, sine a sine b, so I'm going to multiply this numerator by sine a sine b, and this whole denominator by sine a sine b. So this is going to cancel with those two, so I'm just left with 1 in the numerator. I multiply this by this big fraction here. These cancel out, so I'm left with the cosine of a cosine of b minus, I multiply this by 1, so I get this sine of a sine of b. And hopefully you notice, oh look, those two are the same, so I really have the cosine of a plus b, which I can rewrite as the secant of a plus b. And now nobody's looking. I got it without doing anything tricky. Okay, again, so I'm going to work on this side over here, but I'm just going to rewrite this side over here as 1 over cosine 2 theta, just for the time being, because hopefully you recognize that secant is just 1 over cosine, so I can write it like that. So I'm going to rewrite this in terms of cosines. So this is 1 over cosine squared theta all over 2 minus 1 over cosine squared theta. I have a common denominator of cosine squared, so I'm going to multiply by cosine squared over cosine squared. My numerator just becomes 1. My denominator becomes 2 cosine squared theta, and then I multiply this by this and get minus 1. Well, I know this is one of my cosine 2 thetas, so cosine 2 theta, which is equal to secant 2 theta, which I get a check. So nobody's looking. Nobody even know I cheated. Okay, this one's actually pretty involved. So I know that tan theta is 1 plus cosine over 1 plus sine over cosine. No, 1 plus sine over 1 plus cosine theta. Sorry. So this is 1 minus the sine of theta all over 1 plus cosine theta. This quantity is squared all over 1 plus the sine of theta all over 1 plus the cosine of theta quantity squared. So I get 1 minus sine squared theta, and I'm just going to leave the denominator as 1 plus cosine theta squared for the time being, and 1 plus sine squared theta all over 1 plus cosine theta squared. So I have a common denominator. I'm going to multiply top and bottom by 1 plus cosine quantity squared, 1 plus cosine theta quantity squared. So this over here is going to give me 1 plus cosine theta squared minus sine squared theta. And because when I multiply this and this, those two cancel. So again, I multiply this 1 by 1 plus cosine squared, cosine theta squared, and then this cancels to that, so I get plus sine squared theta. Now I'm going to multiply this, so I get 1 plus 2 cosine theta plus cosine squared theta. Oops, that's a minus. Minus sine squared theta all over 1 plus 2 cosine theta plus cosine squared theta plus sine squared theta. Okay, so this sine squared plus this cosine squared equals 1. And since I want my final answer only to be in terms of cosine, I'm going to change this sine squared into 1 minus cosine squared theta. So let's just draw a little line here. So I get 1 plus 2 cosine theta plus cosine squared theta minus 1 minus cosine squared theta all over, these two become 1, so I get 1 plus 2 cosine theta plus 1. So let's distribute the negative, so I get 1 plus 2 cosine theta plus cosine squared theta minus 1 plus cosine squared theta all over 2 plus 2 cosine theta. So these two ones cancel, and these two together make 2 cosine theta. So I have 2 cos theta plus 2 cosine squared theta all over, I'm going to take a 2 out of the denominator, so I get 1 plus cosine theta. Hopefully you see where this is going. Let's just take out a 2 cosine theta out of the numerator. So 2 cosine theta, 1 plus cosine theta, all over 2, 1 plus cosine theta. Those two cancel. The 2's 2 cancel, and I get cosine theta. Okay, so here I have two fractions. I need a common denominator. I could work on this side here, but it's going to be a little cumbersome. I'm just going to work on this side over here by getting common denominator. So I'm going to multiply this one by, so I'm just going to rewrite the problem here. Hold on a second. Okay, so I just rewrote the left-hand side. I'm going to use the common denominator, so I'm going to multiply this denominator with this guy over here. So this is cosine of theta plus sine theta all over cosine of theta plus sine theta. And I'm going to rewrite this side, multiplying by this common denominator of cosine theta minus sine theta all over cosine theta minus sine theta. So I'm going to multiply the numerator now, and I get cosine squared theta. Oops, I don't want black. Excuse me, I don't want red. Cosine squared theta plus, when I multiply this stuff, I get 2 cosine theta sine theta plus sine squared theta minus the quantity. Multiplying those two, I get the same thing, except I get a negative 2 sine cosine in the middle. 2 cosine theta is sine theta, and I get plus sine squared theta all over. I'm going to multiply the denominator, so I have no middle terms since these are, I don't know what you call it. Doesn't matter. So we get cosine squared theta minus sine squared theta. So I'm going to distribute this negative. I'm going to rewrite the denominator as cosine 2 theta, because really we have 2 tan 2 theta here, which I'm going to write a little note is 2 sine 2 theta all over cosine 2 theta. Okay, so this cosine squared plus sine squared is 1, so we get 1 plus 2 sine theta cosine theta. I just switched the order, hope you don't mind. Distributing this negative, excuse me, let's first just make this 1. So these two together make 1. So this is negative 1 minus 2 sine theta cosine theta. I don't know why it parentheses there. All over. I'm going to make this cosine 2 theta. There's my denominator all set. So I now have, distributing this negative, I have 1 plus 2 sine theta cosine theta minus 1 plus 2 sine theta cosine theta all over cos 2 theta. These two ones cancel, and this becomes 4 sine theta cosine theta all over cosine 2 theta. Hopefully you notice that this numerator up here is 2 times 2 sine theta cosine theta. So really this is 4, which is what we have here. So I'm going to take a, sort of, not really take a 2 out, but just write 4 as 2 times 2. Sine theta cosine theta all over cosine 2 theta. So this is 2 sine 2 theta all over cosine 2 theta, which is equal to 2 tan 2 theta. So again, just so I don't get in trouble for working on both sides of the equal sign, that's gone.